welcome to the class. Let me know if you have any question for me. Okay, so let's get started. A very interesting topic, important one as well, because it has direct application. You may have one on your next homework and also for your project. Okay, so as I was mentioning earlier, maybe I referred to it earlier casually in my previous lectures. It's very important for us to make sure that the data that we are using for modeling is clean. Okay, well, it can happen if you're working on somebody's data. Say if you in the last class, right, I did mention this thing like how can we get the data, right? So we discussed about different sources of data. Now, one of the possible source that I discussed was of, say, getting the data from some researcher, right? So now, and I also mentioned that it's getting very common day by day that the researchers, they make their research available. That means their research paper, they make it available along with their experiments. It's up to them how they are doing. I would assume maybe they'll use GitHub. So chances are pretty high that the data that they will be sharing would probably be already cleaned, right? Good for analysis. So that's an ideal situation. If the data that we got for modeling is clean, very good. Somebody has done it for us, okay? But we should be prepared. In an industrial setup, I would say, if you're working as a data scientist, let's say in Amazon or any other Google, Facebook, or any dream company of yours, or maybe in a startup, chances are pretty high that you'll be given the raw data. Now, if the data is raw, then it will have a lot of challenges, right? So we will have to see whether the data is in good shape or not. If not, then we'll have to clean the data. So that's what we are going to discuss now. Cleaning the data, we need to clean it because yes, if the model that you have built is based on the garbage means if we have some noise on the data, then yeah, most probably the predictions that we'll be making out of the model that we have built on the data with noise may possibly give us the garbage output. So garbage in, garbage out, very, what I'll say, a popular phrase that is used in machine learning fraternity and also in data science, data mining, data analysis. Okay, so here we go. Many issues will arise with the real data, and yeah, we need to make sure that for sensible analysis, our data deals with these issues. What are these? We need to understand the difference between error and artifact, a very important concept. So guys, please pay attention on that. I've asked this question in the past. Probably I asked a direct question in the past, like the difference between these two. I don't know. But yes, we need to understand what's the difference between these two terms, okay? And in the exam question, could be direct or indirect. Let's not worry about that for the time being. Let's make sure that we understand the difference between these two terms. And I remember in the last class, at the end, I did drop another term here. Error, artifacts, and outlier. We'll discuss about that. So, outlier, okay? Because I added outlier because I remember a student asked me when. So what we have to discuss in the next few slides, we will, try to understand the difference between these two, error and artifacts, and we'll also understand the issues that may arise because of data compatibility, right? So we'll look into data compatibility and unification issues. We will look into imputing of the missing values, right? So these are a few things we have to see, imputation of missing values. And the last interesting topic would be the outlier. So the outlier that we have over here is the last bullet that we need to discuss in the remaining part of this lecture slide. Okay. Right, so guys, now let's try to understand what's the difference between the term error and artifact, right? So, error, as you could read, let me read that and then I'll explain. The data error represents the information that is fundamentally lost in the acquisition process. Right? So it depends on, see, some of the data that we will have would be coming out of some sensor. We discussed about sensor data also, like Internet of Things we discussed, and there we had the understanding that these are the smart devices connected together. That's one possibility. So the message is that when you're collecting the data, and if that data is coming from some sensor, then the chances are that sensor may malfunction at times. Okay, so as an example, as I could recollect, if the data that you're getting is from a sensor and the data is being recorded at a server, and something happened to the server, and server was out of service for say 1 hour. So that data which was collected by the sensor is gone. There's no way you can retrieve that data. Am I making sense? That is an error. Okay, and we can't do much about an error. Okay, as an example, okay, what could be an example of another error? Can anyone think about an error as I pointed out? One, as I mentioned, we're getting data from sensor, data is going to the server stopped working. Or maybe the sensor could malfunction as well, right? And then that could be related with the precision of the measuring tool also. Okay, so the issue is that the data that we got had an issue that we cannot fix. All right. Any other example of error that you can think of? It has to do with the acquisition process. What's this artifact? It's important for us to understand that artifact is different from error. And I have an example to highlight this thing. So the artifacts are, let me read it, this is very nicely said. These are the systematic problems. Here we go. Artifacts are the systematic problem. They arise from processing done on the data. We have a very interesting example. I'll go over that. It's based on the research by our professor, the author of the book. He has, shown that result. I'll go over that result. But what we need to understand is that the artifact is something which would be introduced on our data by our processing of it. Okay, so here we have something in our control. Artifact is something we can fix, right? So it's possible that the raw data that we had did not have an issue, right? But this artifact is something we introduced because of our improper handling of the data, right? As an example, this is not there in my slide, but just thinking about it, if you are doing some computation, and in doing some computations, you had to divide by some variable, and that variable happened to be 0. It's possible. Divide by 0. Here you go. Right? So these are few things. What we need to understand is the difference. Error happens in our data because the information is fundamentally lost. We can't do much about that. But the artifact that is being introduced on our data is related with the processing which has been done on the data. Therefore, first of all, the most important thing that we need to understand is that we need to detect the artifact. If you don't detect the artifact, then not much can be done. Right? You'll have to see, okay, fine, you know what, this doesn't look good. Right? So that's another challenging issue for data scientists. Always looking for something, right? So here it has been mentioned as a sniff test. So it's very important that you should be able to detect. You should be looking for any possible misinformation, error, or artifact. So the key to detecting the artifact is the sniff test, examining the product closely enough to get a whiff of something bad, right? So it all depends on us individual, right? Sometimes when you read good book, you end up improving your vocabulary as well. Anyway, so let's look at the example where in the analysis of a result of a research or data, authors found something very, very interesting. So what they did, the analysis is not exactly what Google Ngram did, but very similar to Google Ngram. Okay, so what they did, let me read their research. They were studying, they were doing bibliography study, means they were looking at the authors and their publication, and they found the publication of the authors on PubMed. PubMed is a library where research articles are published, and I think that's related with medical science research. Anyway, they were interested in analyzing the work of 100,000 most frequently cited authors. Right? So these are going to be 100,000 top researchers in medicine. Right? They got their they selected, right, from that data that they had. They said, okay, fine, let us focus only on these top researchers, top 100,000. And they wanted to see, like, when did they publish their first paper? We need to understand the problem. Very simple. The top ranked researchers, top 100,000 from, they got the data from PubMed, and they said, okay, fine, we have their paper. Now let's see how many of these people published their first paper in year, say, 1960, 1961, so on and so forth, right? So that was their analysis, and then they were expecting something, right? What would be your expectation actually? Whenever we are doing some analysis, we should also have some expectation, because this expectation will help us in identifying artifacts. Am I making sense? Right? If you have no idea about what to expect, whatever you will be getting, you will take that, okay, fine, looks good, right? And if you remember in the previous slide, we said that for artifacts, important thing is we should be able to identify artifacts, then only we'll be making any attempt to sort that out. Okay? So now here is this question for you. When this analysis is done, let me read that again just to make sure that I didn't mess it up. In a bibliographic study, authors analyze, authors means the author of her book, Professor Skinner, and his research team, they analyze PubMed data to identify the year of first publication for 100,000 most frequently cited authors. Now the issue is that, yeah, there should be some expectation. So it's a question for us. What should be the distribution of new top authors by year look like, right? So now here again, let me read this point. It is important to have a preconception of any result to help it elaborate. Okay? If we have some idea about expectation, then only we will be able to realize whether there is some issue or not. Right? So this is what they found, right? I did ask you, probably you had some picture in mind, but this is what they got, right? Now, well, they had some idea, right? They were definitely not expecting this kind of distribution, right? So they were able to identify that there is possibly some artifact. This is not what we would expect, right? Because these peaks are not explained. It simply says that, there was a lot of research around, say, 1965. It if I put approximate, then after that there was nothing in this period, and then again there was a hike in 2002. Good. So this is something which is not expected. So because of which they could say, okay, fine, most probably we have an artifact here. They went back, looked at the data, and they found out that there was an artifact, and it was because of the way the data was collected. So here is the explanation. So what happened? PubMed had changed their the way they were storing the data. So let me read that for you. So what PubMed used, their author's name was changed in 2002, right? So here, around this time, the format of the data got changed. So what happened, like initially, when the name was stored like SS, and then the last name Skinner, around 2002, they changed the name format and they had full first name, then the middle, and then the last name. So by just fixing this issue, right, so there was an artifact. The artifact was not because of the people who were processing the data, it was in the way the data was stored, right? But it's the responsibility of the person who's analyzing the data. So they fixed this issue, and then after cleaning the data, they got distribution like this, which is much better than this one. So now, honestly, even after reading that thing multiple times, I was able to understand that yes, we need to identify artifacts, and then we need to fix it, right? And for artifacts identification, we should have some preconception about what we are expecting. Okay, we should have some preconception about what we are expecting, then only we will be in a position to spot an artifact. And since the artifact is something which we can fix, so we should fix it. Error we cannot fix. Okay, any question on this? Alright guys, so let's keep moving now. What we will discuss is going to be comparatively straightforward. So data compatibility is a very important issue and we should not ignore that. So it is important because in our analysis we may have to compare, we may have to combine the data that is coming from different resources. So we should make sure that we are in fact doing an apple to apple comparison, not apple to orange, right? So this is the common phrase that we use in our day-to-day life. But in data compatibility, what are the issues in the data compatibility? We should look at the unit conversion issue. We should look at the number representation. We should look at the name unification. These are a few issues. And we should also think about time and date unification. Okay? Last point, financial unification. So before I move on to the next slide, let me tell you that these are the 5 points for which a question in the practice quiz was asked. And I said, ignore this because we did not learn about it. Right? So these are 5 points that we need to, these are these are the 5 points that we are learning in the lecture. It's possible that you can come up with the 6th one. Okay, so these are a few topics that we will look into and are related with data compatibility. Question? Let's get started. Okay, so guys, it is such an important issue that even the people, I would say smartest people working in NASA, right, they had to face the loss of approximately $125 million in 1999, right? So why am I emphasizing in 1999? The $125 million in 1999 would be a lot more in 2025, right? You can probably search it up and you'll get an idea about how important, how much was this amount. Now the question arises, like what happened? So they had this project, which was NASA's Mars Climate Orbiter. It exploded in 1999, and what was the issue? The issue was as simple as metric to English conversion issue. I don't know the exact detail, we can explore that, but yes, the problem was about compatibility. Okay, unit conversion, I would say. Unit conversion issue was there. Metric to English conversion issue, right? Now, do we understand what's metric and English unit and metric unit for measurement? It's not that difficult, general knowledge, very basic general knowledge, right? When you'll be preparing, I'm sure you would know, but example, let's take some examples. Your weight, right? So how is our weight reported, right? How do we fill it up here? When we go to the, I don't know, you must have gone to the doctor, right? When the doctor takes your weight, then what's the unit they use? Yep, ounce. Now, is it metric? Is that in metric or English? If we figure it out, then we would understand what is this English system and what is the metric system. So, ounce is English or imperial system, they say, right? So the pound for weight, pound and ounce and all, this is English imperial system. And if we follow that kilograms, grams and that unit, then that is metric. Right now, the other thing will fall in place. Like for distance, if you're using feet, miles, and yards, that unit, then that is English and imperial. And in metric, it will be meter, centimeter, and kilometers. Similarly, for for volume, gallon and all, this is English, whereas liters, milliliters, that's your metric. So yes. Now, interestingly, we need to stick to one measure. We should be careful about these issues, right? When we are combining the data, it may so happen if you're getting data from two different sources, make sure that you understand the unit of every column, which is often, I have done that, right? I don't look at the units, right? So if you're working on a data science project, you got your data, make sure that you even understand the units in which the data has been reported. Now, interesting is the fact that even if you're committed to using just one system, like metric system, then there are potentials, right? Like say centimeter and meter. It is possible that some length measure can be is reported in centimeter at one place and meter at another place, right? Is that possible? Can you think of an example where for some measurement at one place it is reported in centimeter and another place it is reported in meter? Yeah. Here you go. Right? Height, it's very normal, right? Sometimes, when I look for, for the height of some sports personality or maybe celebrities and all, I search it up. Sometimes it is reported in meters, sometimes in inches, and if you ask me, let me ask you guys, right? For the height, right? What metric is more convenient to you, right? If I ask you what is your height, how will you say it? What is more common in our day-to-day life when we are talking about somebody's height? What unit? Feet and inches, right? That's the case with me also. So the issue is, in our day-to-day life, that is fine. Feet and inches is okay. But when you're doing data analysis or data science or machine learning, it should be reported as, what's the problem with feet and inches? Yes. We have nothing against English, right? We are speaking English. Okay, fine. Yeah.
Because the right feet
there are two values, very good, right? There are two values. Fine, as we are talking, that's perfectly all right? Because that's in our language, right? Maybe I can guess your height, right? If somebody just stands up and says, guess my height, I will be able to do a good job when I think in terms of feet and inches, right? The way we say. But we'll go over that, right? It's better to have one number, right? Either in centimeters or in meters. Single number. Right? Let's not have two values, just one number. Yes. Good. Okay, can I ask you this question, right? I'm assuming that you all might be taking flights regularly, right? So, how many of you are like me who would look at the map, right? Do you look at the map, how far you are from the destination? Sometimes it also helps that you would see which country you're flying above and all, right? So, what's the unit of the altitude of the flight? Flight altitude, am I making sense? Right? So, how do they report? Yeah. Sorry? Your height in miles or the distance in miles? How high you are flying above the ground, right? That is in miles? That is it? Come on, you're all guessing. Altitude is in feet. Think about it, why it is in feet, right? I searched it out. It's very interesting. It has to do with the precision, right? They want to be very precise. Even how much is a feet? Probably this much, right? Meter, I don't know. So precision, they want it to be so precise, right? The altitude is should be very precise. There are so many flights. Right? So anyway. Okay, so now this is an interesting observation. Could be a possible question. How? I don't know. The bimodal distribution. You know what? Last year while teaching, I called that binomial, bimodal. Bimodal distribution. What does that mean? Bimodal. Can you draw any bimodal distribution? Yes. It's much simpler than the question. Bimodal. What should be there in the bimodal distribution? Yeah. I think you got it, right? This thing. Sorry, but this is too steep. More than one mode, that is bimodal. More than one mode. Right? It should not be of the same height, right? This is bimodal. This is bimodal. Any distribution with two peaks. Why are we discussing about bimodal here? Well, we are discussing about bimodal for the reason that bimodal distribution can indicate double. If I were to put this question in the exam right now, I'll say, you are dealing with the data, right? And you found bimodal distribution. What can that indicate? And you have the same kind of data. The same data you're getting from two resources, and you got a bimodal kind of distribution. What could that indicate? It's very, what I'll say, open-ended kind of a question. Issue is that it can arise because of the unit issue. As an example, I have 110 students here, 118 here, 110 in the other class, right? And let's assume that all the students are coming from the same population, okay? And I'll let all the students sit at one place, just making the problem a lot simpler. And I would say, I'll ask one of the TA to take the heights of, this is maybe 220. Half of the students' height, one TA will take, and the remaining half population's height, the second TA will take. And I'll say, guys, okay, give me the data and I'll plot, right? And I get this kind of distribution. So what does that indicate? That indicates that probably the measurements that we have are in two different units. Is that making sense? Otherwise, it should be just one, right? It's coming from the same population, so it should follow normal distribution, right? But since there are two different modes, right? Probably it can indicate that yes, the issue could be because of two different units. The TA who measure the height in meters will be smaller, will have a smaller height value, right? And the other one with centimeter will be on the right. So I hope this is making sense, right? If not, let me know. There's some issue with the mic today. Multi-model, you understood the issue? Z-score, again a very interesting thing, right? Do you, I would assume that you know about Z-scores, right? Yes, no? How to compute Z-score? See, if you're familiar, just say yes. I won't ask you the definition. If you came across it, great. That doesn't mean I will not explain. Anyway, I will explain. I'm probably teaching a lot of things which have been already taught to you people. Okay? How's that Z-score computed? Let's get that first, right? I never asked, but I must ask this question. It's such an important measure, right? Z-score, how do we compute that? Okay. If I, well, this will happen, and it should happen very, very soon, okay? Should definitely happen before we meet in our next lecture, which is the grading of your quiz, right? So if we release your quiz grade along with, okay, I'll only release your quiz grade, right? And I'll say, okay guys, now we need to compute the Z-score of every student's grade, right? So what else would you ask me for? I will only tell you your grade, right? You won't be able to see the grade of all the students. I'll only give you your grade. And I'll say, okay guys, tell me what is your grade in the Z-score? Yes. No problem. Very good, you solved the problem, okay? I'll give you 75% of the question. Because we need what?
Is it the formula 1 minus mu over?
We'll get to that formula, but we sorted out one important thing, that when we have to compute the Z-score, we need the mean and the standard deviation of that population, right? And let's not get into the trouble of, okay, standard deviation I'll compute, right? That will be the population standard deviation, because I know the whole population, I'm not doing any sample, okay? I'll compute that and I'll give that to you. Now, for any student, right, Zi could be Zi, which is the Z-score of ith student, right? Let me take you, would be your score minus mean of the score divided by standard deviation. Good? Right? Now, why did we do that? We did some computation, right? Maybe NumPy will do it very, very fast, but I'll make you do all these calculations in the homework is fine. Midterm exam, we still have time, but yeah. Why should we compute it, right? Is there anything interesting about Z-score? Please go ahead. It will be an indication of volatility. What is it? I have no idea about that.
It's like how random the data can be, whether or not the data is like close together or not.
Do we have any term like volatility? Actually, maybe I have to check. Don't mind, right? If you're using it, let me explain it to you, right? When I'll be asking this thing in the exam, like why is the Z-score important? That the issue is probably dimensionless. But that's there, it is dimensionless. It is dimensionless, right? How to prove it that it is dimensionless? It's very simple proof you can do it. It is not much. It is dimensionless, right? Because see, if this is your, for grade we don't have any unit, right? Let's assume that this is your height. Okay, if this is your height, then height will be in inches, right? So this is in inches, this is in inches, the difference will be in inches, standard deviation is also in inches, inches cancels out. It's a dimensionless quantity, right? So that's the beauty. And now what does it indicate? Somebody pointed it out earlier, right? Okay, another possible question on z-score. Your z-score came out to be 2.5. What does that indicate? Your z-score is 2.5. What does that indicate? Right on the mean, right side on the mean, right? It's that simple. Okay, just think about it and write that neatly in English. All right, making sense? So guys, the message is that, and we will mention this thing in future as well when we learn about linear regression. That for linear regression also there are some recommendations that when you have to apply linear regression, what should you do with the features? What should you do with the independent variable? And one of the suggestions is that we should convert that into z-score. Yeah, so here is the message that yeah, vigilance is very important in data integration. Now, let's look into another event or accident, whatever you call it. The previous one was with NASA, and this is about Ariane 5 rocket. And this time I searched it up, and unfortunately it was from European Space Agency rocket. It exploded in 1996, and the cause of this failure was a data conversion, right? So a number which was a float 64-bit was by some error converted into integer. 64 float to 16-bit integer conversion. That resulted in another loss of around $500 million, and that happened in 1996. Okay, so yeah, these are I'll say these are some examples that we should know, keep in mind when we are learning about these topics, because these are important and these things have happened in the past and by some smart people only. No. Now, the recommendation is that we should be very careful about how we are measuring how are we taking data, what should be the unit of our data. Measurements should generally be in decimal numbers, like your height should be in decimal number. You can pick it as maybe meters or centimeters or inches. And the count should be an integer, right? So we should decide, okay, what goes in floating point data and what goes as an integer. And here is this thing that we already discussed, right? Fractional quantities are good for our day-to-day communication, but for data, it's not a good idea. So the fractional quantities should be decimal, not like pounds and ounce, feet and inches. They should be rather represented in one value. Question? Okay, now even more interesting, right? Name unification. I will take the example of Professor Skinner only, but I felt that in my name also, and you might have faced that issue with your names also. So let's look at his case, his examples, and we will understand what is the issue that might arise in name unification. So we didn't discuss about name unification, but if you remember, when I was telling you about the artifact, so that had something to do with the name only. So the name was stored in PubMed in one format till 2002, and after 2002 they changed the format, right? So because of which there was an artifact introduced in their analysis. Now, when you are dealing with the name, then you may come across the scenario like for a single person, our process Kina. Well, let's look at this part. It's your first name. Then this is your middle name, and then you have last name. Right? So there are 3 possibilities for the first name, 3 possibilities for the middle name, 3 possibilities for the last name. So 3 multiplied by 3 multiplied by 3. Right? So these many, 27 if I'm correct mathematically, different names refer to single persons. Right? Well, this is an issue we need to resolve, right? When we are dealing with the text data where we have the information related with individuals. Now, the question is, how can we, now this is something you need to think about, right? Which could be a question, like what issue or what approach you will take to make sure that this kind of situation does not arise. The problem is clear, right? The first name can have variations, as you can see. The middle name can also have variation. The last name can also have variation. I'm asking because if I can, let me see if I could get something which I don't have in my lecture slides, right? Any suggestion, smart move that you can do, right? If you face this issue, right, then how will you fix it?
Like that, applying regions.
Sorry? Applying regions, you're saying? Regions. What is it? You need to explain. So regular expressions. So that's a solution, right? That you will apply very good. So what you're suggesting is something that you will do in your analysis, right? We are discussing if we can make this system a little simpler. Yeah, that's smart. You will do that, right? You are saying, okay, fine. I will do something during the analysis in my program that I'm writing. I will use regular expressions. See what suggestion we have over here. Well, change everything to lowercase and then remove the middle name. So if you remove the middle name, then yeah, the factor of 3 is gone. Right? First name and then there's some issue with my microphone today. Probably it was too close. Anyway, so one of the solution is that we can transform the names to lowercase and we can take off the middle name. And the other very interesting thing is to use something called as phonetic hashing. Now this is interesting, right? Like what is phonetic hashing? Are you aware of phonetic hashing? Soundex, what is it? Metaphor, what is it? Hashing, phonetic hashing. What is phonetic here? And how can that be useful? That's a question, right? Interesting midterm question, phonetic hashing. What is it and what could be its application? Where can we apply this in the data science project or data science problem? Phonetic, we understand what is phonetic? Phonetics means having to do with the sound, right? Phonetics. I learned about phonetics in my undergrad only. It was a course in, I think, English, technical writing or something. And we learned about it, like how to pronounce the word, and then there are some interesting symbols for R, A, I, E, O, U, all those kind of sounds, right? So it has to do with the sound. Now the solution to this problem, where we can have multiple different spellings for the same sound, in phonetic hashing, what is done is that those spellings are hashed to a sound, right? Hashed to a sound. So Skinner, if that's the sound, all these three spellings that you have should hash to the same sound. Is that making sense? Right? Now these are the two approaches, soundex and metaphones. Metaphones seems to be two approaches that support phonetic hashing, right? So this is one solution possible for name unification, but then it again has issues like we will have to deal with false positive and false negative. This might go in your homework. Question where I want you people to explore more. Yeah, go ahead.
Those are all run once to the same,
Yeah, same.
But then when you have words like read and write, that might are different, right? But they come to the same thing.
So that will be false positive and false negative. So the last point that we have is about the trade-off, right? It will introduce false positive and false negative at the same time. Although it's a solution, but the solution also has some disadvantages. Yeah.
Are the three options misspelled or are they alternative?
You mean the last name?
Yes.
They could be misspelling as well, yeah. They could be misspelling as well. There may be a smarter way of figuring it out, right? But right now, since we are learning data science, we need to know about the challenges that we may have to face, right? Yeah, they could be misspelling as well.
So why are we trying to group them in terms of phonetics rather than their spelling?
That's what approach. Phonetic is one of the approach possible that we can use because the spellings could be different, but the sound is going to be the same, right? So that's an intelligent way of hashing even the misspellings to the same person. I would let you people think more on this, most probably as a homework question. Wherever I believe that the student should explore, I will do that as a homework. But for you, in the exam, you should be aware of the context, right? I remember, so since if I discuss it, then I may not be asking this. I asked a direct question in the quiz probably, like, what is sound X? And probably 90% students had no idea where was this discussed, sound X or metaphor. So remember the context. The context is that we discussed about it in the name unification case. Now date and time unification is also very, very important. Let me read and then I'll explain. Now aligning temporal events from different data sets or system can be problematic. So what is the solution? The solution is to stick to one time frame, like all the data should be converted to UTC. As an example, say if some event happened something happens in something good. Let's think about something great happening in New York City right now, which should be reported at multiple places, right? Say a concert happened or a game happened, and that game, international soccer event happened. Let's think about it, right? Two big teams, they played soccer in New York City. And whatever was the result, and let's assume that it is being watched by people all around the globe. They will report that event as per their time zone. Is that making sense? Right? We will report that event as per our time zone. So, although it's happening at one time, right? But since people are sitting in different part of the world, right? Maybe it's a night for them, maybe it's morning for some of them. So whenever we need to understand this thing, because when we have to combine the data which is coming from different resources and it has time component there, then we will have to first arrive at a common time unit, right? So for this, UTC is pretty good. In fact, this whole topic is very, very important. Okay. Any other suggestion, or are you aware of any other time unit where we don't have to think about it? Some of you are aware of this, right? Any unit in which the time should be reported so that we won't have to worry about this date and time zone, daylight saving. There are so many factors, right? Time is not an easy thing to figure out. Like daylight saving is there in USA, most probably it's in Canada as well, but probably it's not there in countries like China and India, right? So my question is, do we know about a unit of time where we don't have to worry about these issues? No? Yes, go ahead. It's called Unix time. Right? Search it up if you're taking Unix time. It's also called epoch time. You're correct. So that is what the number of milliseconds elapsed from January 1st, 1979 in UTC. Okay, so it's the same reference for all of you, for all of us, and it is going to be a big number, right? It will be, for us, it will be very difficult to make sense of that. It's a huge number of milliseconds, but for data analysis, it's just very convenient. Now let's look into the second bullet, which is slightly tricky, related to the time only. Now, if we have to deal with slightly more complex problem, like we are doing some financial time series analysis, then it is going to be very tricky because the financial data won't be available on weekends. So, like on the weekends, we don't trade. Same is the case for holidays. Now, if somebody has taken this interesting project of correlation between stock prices and temperature, then yeah, we need to figure it out in the sense that we will have to only consider the time when the trading was done. Financial unification, let's look into that as well. And this is slightly tricky, where you will have to do some homework to understand. I did some homework. I don't know how good I can communicate that, but let's see. First thing, which is simpler one, is that whenever we are getting the financial data from different part of the world, from different countries, then we need to first of all consider the exchange rate. By considering exchange rate only, we will be able to compare the prices of something. Say, iPhone. What was the recent iPhone? iPhone 7. Okay, right. The sale of how much was iPhone sold, right? Let's think about the not the number. I'm intentionally making it more complex. Like how much? Let me figure it out. How much they sold in the terms of for how many dollars, right? So if we are getting that data from say UK or say for Europe, right? India, China, USA. Now you would understand that that will be reported in their own local currency. We need to put that into one, right? So how to do that? We'll apply the exchange rate. And guys, these are few things you are supposed to know, exchange rate and all, right? If you're not comfortable, please do that homework, okay? While preparing for the exam. And when is the next exam? You should say, okay, give us the grade first, then we'll think about, give us the quiz grade, then we'll think about the exam. But we'll grade it quickly, okay? When is the midterm? Next week, Thursday? Next to next week, right? But probably in that week we have the fall break also, right? If I'm not mistaken. So what I'll have to do, somebody should remind me about it, right? I should be doing a review next week on Thursday, because most probably then we'll meet for the midterm only, if I'm not mistaken, right? Anyway, and now guys, this is very important, right? This is where you'll have to search it up if you're not familiar with how the stock prices work. Now, it is very, very common for the companies to split their stock, right? They split their stock and they also offer dividend. So because of the stock split and because of the dividends, the prices may change a little bit, and they do change, right? So whenever we are doing any analysis on the stock prices, then we need to consider these two factors, stock splits and dividends. And one interesting recommendation that we have is for returns. Whenever we are dealing with the returns, then the return should be quoted in percentage change instead of this the absolute price. And this is the most interesting one, which is the fact that we should, when we are dealing with the financial data, then we should consider inflation as well. And what is inflation? Again, these are some homework kind of a thing, but let me say if we have understanding of what is inflation, right? How many of you are comfortable with what it is? We don't have to define. But any understanding of inflation? Raise your hand. 1, 2, 3. Reasonable, right? Fine. Make sure that you understand inflation, right? I don't intend to provide you the definition of inflation in your cheat sheet. Okay? With data science, we'll have to learn, improve our general knowledge as well. Inflation, okay, can anyone define in her or his word or what is inflation? Why is it important for us? Right? Why should we know what's the rate of inflation? Right? Rate being high, is that a good news? Rate being low, what is good, right? What does it signify?
Inflation is basically prices rising. Ideally, you want a low inflation rate because that means prices are rising at a very slow rate. It's good to know inflation whenever you're comparing like the cost of living today compared to the cost of living in the past.
Okay.
Because those numbers are going to look different because they're not at the same value.
Very good, very good, right? So I think I have it, very good, very good. Seems like you have very good understanding of inflation. So guys, let me read it. Sometimes I have much better information on the lecture slide than what I end up explaining. So here we have it. Inflation kind of conveys the time value of money. So that needs to be corrected when we are doing any financial analysis, right? So as he mentioned it beautifully, right? That the value of dollar, let me put it in my words, the way I understand, the value of dollar 10 years back versus the value of dollars now. Now the question arises, how can you compare the value of dollar, right, 10 years back from the value of dollar today? Can you somehow compare the value of dollar? This could be a very tricky, interesting question to examine. How do you evaluate the value of dollar? Very good. What could be your item? Like, come on with me.
Rice, meat,
Right.
milk.
Very good.
And then they compare what's the price of that then.
Perfect. Very good. Perfect. Perfect. Right. I was thinking about gold. That also makes sense. But yes, it's very practical, right? Like for a gallon of milk, right? How much you paid 10 years back, how much you're paying now. So if 10 years back, I'm just coming up with the number. If you paid $1.5 for 1 gallon of milk, and if you're paying say $5 now, then you can see yes, the rupee, sorry, the dollar is not that strong. Good. See, what you guys should do. I'll have one lecture. I'll have in fact 2 meetings, 2 lectures before midterm, if I'm correct, if I correctly remember. For reviews, right? You should have your own questions. Then the review will be very, very interesting, right? So, yes. Now, this is again an observation from our textbook where the professor, when the student of the professor, they found the strong correlation between the stock price and oil price for 30 years. The reason was that they did not consider inflation. So inflation was the main reason behind the strong correlation between the price of the stock and the price of the oil. The most important, right? Everything has been important. Like in this sequence, this is probably going to be the most important one. Dealing with missing data. How should we do data? We cannot avoid it. Some data could be missing and we have to intelligently deal with it. Now, an important aspect of cleaning the data is to properly represent missing data. Now, as an example, right, if you are working on some data, all right, where you have the data about, I don't know, let's think about it, right? When would you be concerned about the death year of a person? We should not think about death now, right? Definitely not when people who are too young. But for what data, right? We are data scientists, we have to deal with all the kinds of data, okay? So what kind of data would it be where we are interested in the year of death of someone? That's fine, I'll take that, but okay, then that's one, health related, right? Can anyone think about people who are kind of looking into like when is the person okay, sometimes I have some example and I'm thinking like, okay, who can give you that example?
Average life expectancy.
That's again, yeah.
Insurance.
Here you go. You're thinking like me. That's what I was thinking. Life insurance, right? Life insurance. Probably they are making money from life insurance and all. So that's what I could think of the most appropriate one, where your data is given and you know that there are some people, right? Maybe in their 30s they are buying life insurance. Maybe in the person who is in 50s, who is in 70s, who is in 80s, right? And for some, well, if that life insurance company was in business for say 70 years or so, they will have a lot of data. Right? Also, those people who died, right? But for some people, they will have the data who are still living, maybe in their 70s or 80s, right? And for them, the year of death is not available. Now, question arises: if we were to use all the data, right? And some of you pointed it out, like our model, right? Now it depends upon what kind of model we can build. I'm making it slightly complex, but anyway, for the data, right? If we want to train our model, right? We don't have sufficient data for those samples of those people who have died already, right? So we want to put some value of our own, right? We want to make a guess of the year when a person might die, right? We have to come up with some approach. It's not a good discussion, but let's see. So what would be your guess? Can you think of any approach of missing that field, of putting the value for that field where the death year is not known for a person? Is my question clear? What should be our approach? Yes. Interesting, right? So you're saying that you will find out the mean of the year of death for that column and put that for that individual whose year of death is missing. Now it sounds slightly better, right? But the issue in data science is that you need to think, right? And those boring lectures that I had in the beginning are probably the most vital, I would say, right? Avoid giving the wrong answers, right? So mean is probably not a good measure, right? So what we can do is, let's discuss about it, right? We have some interesting suggestions. So first of all, we'll look into that, right? Keep thinking, and your second suggestion is better. Find out the mean life expectancy or something you said, right? Like how long, that's what we have, right? So for a person whose year of death we don't know, find out the year of the birth of that person and just add 80 years. Assume that the person lived for 80 years. Even smarter approach would be, okay, if you could get some health record of that person, then you can intelligently maybe feed that in a model, right? So those are again something smart you can do, but that's a very that's a valid suggestion. Now, what about a field left blank and filled with an obviously outlier? How does that sound? Right? Is that a good suggestion? Like some values are missing. Let me put zeros there, or let me put some very big number, or let me put some very small number. These kind of things we do in our conventional programming things, right? Does that sound a good idea? Is that a good idea? No, definitely not, right? So this is something we will have to avoid doing. Despite that, some of you will do that in the homework. But please do come and check with me Homework means there will be a homework, probably you'll have this exercise and you'll try all the possible ways, okay? So, now here is the message. Setting any missing value to 0 is generally wrong. Please don't do that, right? Think of something better. 0, negative, or very big number. No, we are not doing that. So let's look into the standard ways of dealing with the missing values. Now, if you have enough training data, one might drop all the records with missing values, right? If you have a lot of data, we will do that. But we may want to use a model on the record for the missing field. This is the most interesting one, smartest one. Now, often it is better to estimate or impute the missing value. That is where we are going, right? And then the most important concept is the imputation techniques. What are the imputation techniques? This is something we will learn, data imputation. So, we will now put some random values, right? Some of you might be wondering where is the attendance sheet. There's a midterm exam in the next class, right? I can see some students outside, so that reminded me of the midterm exam. Okay, so if you have a lot of data, then you may discard some if there are only few records with missing values. And often it is better to estimate or impute missing values instead of leaving them blank. So here is this thing, right? A good guess for the year for anybody's death year would be the birth date plus 80. Now we will look into these imputation methods, very, very important for us, like mean value imputation. This is what our students suggested, right? Like if the field where I have some missing values is for the height, right? If I have the data for my students and one of the field is their height and weight, right? Say somebody didn't tell the weight for any reason. Then yes, for weight, if the weight value is missing, yeah, for that we can use the mean value. Right? That sounds reasonable. And how about it? If there is a field with the household income, right? Mean household income, and the data is missing. So would you suggest me to put the mean as the value for the missing value for household income? Is that a smart way? Is my question clear? What is a smarter way then? Why do you think that mean is not a good way? Yes?
There might be much bigger or smaller amounts that have a much different cost.
So what should I do? I need to put some value here. Yeah.
We can estimate the value with the house size and location of the house.
Median, right? Because for that household income, I would say median is a better one because we may have people with very high household income. So for that kind of data, median could be a better approach. Okay? Whatever I'm telling, please explore those things, right? Is it possible that you can find better solution than what I'm suggesting right now? There's again a very interesting approach, which is random value imputation. Okay, so the advantage of the mean value imputation is that when you replace the missing value with the mean of the data in that column, then mean remains unchanged. You see that? Right? For that distribution, its mean will not change because you're just replacing that missing value with the mean. And in the random value imputation, this is interesting, we repeatedly select random values from that column, right? In place of mean, we'll put some random value, and then we'll see whether this is messing up our modeling or not. Now the most interesting one is the last, which is imputation by interpolation. Very interesting. So what is done in interpolation? Using linear regression, we predict the missing value, right, based on the other values, right? How does that sound? If there are, say, I have same data, right? It's about household income, average household income, and we have some information about that family. Right now, you can think about it with maybe the house that they are living in, the cost of the house. Just think about all those things. But for some records, the household income is missing. I need to fill it up, right? So that is a very good example here. What we can do is, for those, what we can do is we can build a regression model on the columns where we have all the data available, right? And we can use that model to come up with the missing value. This is the most intelligent one, right? And yeah, this is what we call as imputation by interpolation. Using linear regression to predict the missing values works well. Okay, now outlier detection. Again, a very, very interesting problem. Could be a project topic also, right? And you can think about it. Now, this interesting observation, right, from our textbook says that in one of the reports, the largest reported dinosaur, vertebra, is 50% larger than all others. So this is a data error. This could not be an outlier. 50% larger. This is too much. Okay. So what we should do? We should look critically at the maximum and minimum value of all the variables when we are detecting outliers. And as an example, we'll discuss about it. If the data is normally distributed, our next topic is going to be statistical distribution. And in the statistical distribution, one of the very interesting distribution is going to be normal distribution. Now, one beautiful aspect of the normal distribution is that we have, I forgot about that exactly. Does anyone remember what is that rule for? You'll have to correct me. It's 65 or 68? Okay, let's see. 68 or 65? 95, 99 points, something like this. 65 or 68? And then 95 and 77.5. What is it? 68 or 65? 68. Now, the beauty of the normal distribution is that your random variable will take a value in this range. Wait a second. Mu minus 1 standard deviation, mu plus standard deviation. So a random variable which is following normal distribution will be 68% of the time be confined in this range. 1 standard deviation away on the left from the mean and 1 standard deviation away from the mean, right? So in that range you have 68% probability. So and then this 95% is for mu minus 2 sigma, mu plus 2 sigma, and then 99.7 is mu minus 3 sigma and mu plus 3 sigma. So this last bullet that we have here is saying that normally distributed data should not have large outliers, k sigma from the mean, right? So this is again related with the outlier detection only. If we know that our data that we have is coming from normal distribution, we know it's mean we know the standard deviation, then we can find out the probability. Then using this probability, we can figure out whether it's an outlier or it's an error. Now, this is the most important point over here. Fix why you have an outlier, just don't delete it, right? And probably the last slide that I have is related with this only. Detecting outlier, there are a number of ways that we can follow to detect the outlier. So if you can visualize, right, so visually an outlier can easily be detected if your data is that simple. But for that, the data should be in low dimensions, right? As long as, if your data is in 3 dimensions, fine, you can visualize, right? If it goes to higher dimension, it will be very difficult. I mean, from visualization, you cannot figure out unless you use a really sophisticated visualization technique. Now, outliers are the byproduct of clustering. We'll learn about clustering. So if you cluster the data and you find some data which are not falling into clusters, which are very far from the clusters, then they can be outliers. So guys, what is happening, as I can notice, I'm rushing on something which is very, very important. I should not do that, right? So for these points, I will go with the last few slides again. This is another one, maybe the previous one, that we meet next time. Thank you so much. And when you are done with the sign-up sheet, please pass it back to me. See you next time.